All right.
Brings us to our mandatory
requirements.
Does this mean that you can exchange some of these?
What does mandatory mean?
Every house must have these.
You got to do the mandatory requirements, okay? So no trade-offs on this. You got to do them. And the first one that comes up is one that we've technically had in our code already, but now all of a sudden it really matters. And that is this certificate on a panel box. We actually occasionally do run into this under the old code that people have done this, but it was somewhat ignored. It now actually means something pretty important. The idea is that you're going to put a sticker or a label or something that's on your electrical panel box, or I think you're allowed to put it on your air handler if for some reason the panel box is hard to get at. And I like to use the analogy, if you look at a box of cereal and you turn it on the edge and you read it, what is there? A little nutritional label, right? That's kind of what this is for a house. It's just the basic ingredients from an energy standpoint of what's in the house. The label itself does not save any energy. The label itself is a means of sort of communicating what the guts are of this house. Okay? And Georgia added a couple provisions that say we also want this on the label, which suddenly make this label really, really important. One of them is we want a summary of the load calc information.
Yep.
And what's the other one?
Cooling loads,
yeah,
sensible
heating and cooling
loads.
Right. Yeah. And what's the other one, Roxanne?
The other one is the envelope and the duct test results. This means that every house must have a blower door test performed on it if it's single family, and it must be recorded on here. In addition, if a duct blaster test has to be performed on a house, the results must be posted here. So this is why it makes it more important than in previous years, because it's really recording how this house is performing. Mike, if you want to go to the next slide. So here on this one, the top portion of it, that envelope summary, you can follow in a copy of yours if you go to the green tab.
It's almost like the very last page of
So yeah, go to the green
handout.
tab, the first page there.
First
So that
page?
first top section, it's going to be predominantly filled out by the builder, and that's the R values, solar heat gain coefficients, the U factors.
Builder or designer is what the code says. So if it's an architect doing this, the architect might fill it in. But generally, it's the builder.
The last portion of the envelope summary is the BET test portion. That's going to be done by your DET verifier. This is the blower door test results or the envelope test results. And, for better or for worse, the DET verifier is going to have to put their name and number on it because they're going to be held responsible for these results later in life. The mechanical summary is the next portion. This is going to be part of your heating and cooling equipment, with exception to the first thing, which is the water heater energy factor.
Most of this is HVAC stuff. Yeah.
With exception to that, it's HVAC stuff. And so this is where you're going to be putting your load calculation results as well. The bottom portion of the mechanical summary, the duct tightness test conducted by, is going to be filled in by the DET verifier again if you're required to do a duct blaster test or a duct test.
Okay.
Is that kind of fair, guys?
We'll go through this in a little more detail about what some of these things mean, but basically the bottom line is the test results have to be on this sticker. So we're not only do you have to do the test, but the test has to stay, in essence, the results have to be posted, and you got to put your name on it. So, all right, we're going to cover those in more detail, what the tests are. Another big thing that is required is that you must do air sealing, okay? Air sealing is very, very strict, or is very, very explicit. Every version of the energy code beefs up the requirements to do air sealing. So there's a very detailed list, starting right here with everything must be air sealed, all joints, seams, and penetrations, followed by number 2 through 11, basically 10 more places that we're going to specifically spell out for you to air seal, followed by number 12, Roxanne. What's that one?
Oh, if we forgot to tell you to not air seal something, all other sources of infiltration. So to recap, seal everywhere, pay attention to 10 crucial spots, and if we forgot to tell you to air seal the place, air seal it.
Right. So
got that redundancy going on.
So are there any excuses for not sealing something? You must seal everywhere. That's basically what it comes down to, okay? You got to seal everything everywhere, including, you know, all these specifically spelled out places. So we put some good graphics together to help show places to do air sealing, and they are in the supplements and amendments. And also there's some specific places that were called out by the code to do air sealing. And one of those is wood-burning fireplaces. Okay.
So,
right. So John, are you awake now? This is definitely going to grab you here.
Just for the gasketed doors at this point, and they make it cheaper. But at this point, your special order, they're $500 a fire.
Well, I've got some good news for you. I got some good news for you. Okay. Or I don't know if it's good news or bad news for you, but I got some news for you. So first of all, we're going to explain to you how it is written in the code, and you'll understand that it's very vague the way it's been written. Yes, actually there is.
all right, cue Bill.
Okay, Bill. So first of all, before Bill talks, let me say the way the code is written is it says, quote, new wood-burning fireplaces shall have gasketed doors and outdoor combustion air. Those are both a good idea, particularly the combustion air, okay? Particularly combustion air brought to a firebox. But I think that some folks looked at it and said, this may be more than what we intended. So I'm going to turn it over to you, Bill, to
Multifamily, a common one, Mike's drawn it, is 3 stories, 4 units per floor. If this building were to use the checklist approach, every unit must receive actually 2 inspections. They have to have one occur what we call pre-drywall, so you actually get to see the air sealing. And then one
before it's covered up by insulation.
Before it's covered up by insulation. And then a second trip will have to be carried out as well, because just the items on the checklist need to be checked in 2 stages. So let's do the math. 12 units, 2 inspections
per unit
is how many inspections total?
42.
24. I think Mike's just throwing me off my rocker today.
It's dyslexic.
Okay.
Yeah.
That's a lot of inspecting.
Smelling my marker.
So there's a test out approach where you can do a blower door test, 1 per 4 units per floor. That's kind of why this all came about. So that means you can do one test on the first floor, 1 test on the second floor, and 1 test on the third floor in 1 trip, and you're done.
If this one passes, all 3 other units on that floor are assumed to pass. This one passes, all 3 units are assumed to pass. This one passes, all 3 are assumed to pass. Okay? So it's kind of a little bit of a sampling approach for multifamily that you're allowed to do, but only for multifamily can you sample. And multifamily, unfortunately, has the option of the visual inspection. It's kind of confusing. It's kind of a pain in the rear end, but there you have it. So our suggestion is probably you're going to find it a lot easier to blower door test 1 in 4 units and probably cheaper, but it is an option that they have. Okay? Does anybody have questions about that? We did need to point that out, the inspection checklist. Okay.
All right, so we're really focusing on air sealing for this next portion. These are things that, we really want to make sure that we are testing our blower door. You're doing that blower door test. That's what's really going to pick up, right? The blower door test is going to pick up all your air sealing. I can almost assure you, if you had this big of a hole, your blower door test is going to fail. This is a big chase that no one sealed up and insulated over. They just kind of left it there for the elements. And the homeowner from this story was uncomfortable because what's that wire right there kind of hanging down next to the pipe on the right? That's your thermostat wire, and that's just probably not a good place for it to be.
The thermostat was on the back. It was on the hallway side of the drywall right here. And just think about how hot does it get in the attic, right? And what's the R value of a 1/2 inch of chipboard? What do you think? It's about a half, so not much, right? So pretty workable. Like a big comfort problem. Roxanne, what I think is really funny is this part over here.
Oh yeah. Well, clearly somebody must have come in and said, well, you need more insulation because we got 1 type here and 1 type there, and lots of types over here, and a couple more types over there. So, they were trying to address the problem. Clearly, someone was thinking, it's got to be insulation. You're having, air comfort problems. And what they forgot to really register is that's a big hole that needs to be air sealed. It's not just insulation. Remember, we got to have that air sealing and insulation in contact. So,
Well, they had to be getting close to getting it filled up.
They had to be getting close to fill it up, right? Everything's just falling down that hole.
So air sealing is pretty important, and we always say get rid of the big holes first, and then go after the small holes. Here's another example of a large hole. The pipe is this big, but the hole is this big. How did that come about? What precision tool did they use to cut the hole like this? Chainsaw, right? Yeah. So it's fine. Make the hole as big as you need it, but someone has to seal it up. And we're not saying who it is, but someone has to do it. Someone has to be responsible for that. It's some builders manage to get their subs to do that, but sometimes they'll have a separate sub do air sealing. Air sealing is not hard. It's not difficult to do. The only hard part about air sealing is that it has to happen sort of throughout the course of construction. It can't happen all at once, and that's what makes it challenging. You can't just have someone come up one time, spray a magic coating on something, and then the house is airtight. Because whatever you do, people keep making more holes in it. Okay, so that's the challenge of air sealing. It's not that it's hard or the materials are expensive, it's just that you have to kind of stay on top of it. So here's another example of a classic large hole, a duct chase, right? This is going to be a real pain after the fact now to air seal this. This is going to be hard to do. It can be done, but it's going to be hard. Much easier if the framers cap the chase, and then, Ed, you can cut holes for your ducts, that kind of thing. Duct boots poking through the floor have to be sealed. Here they use mastic. That was a great detail. Duct boots poking through the ceiling have to be sealed. You can use caulk or mud or whatever, but it has to be sealed. Electrical light penetrations through the ceiling have to be sealed. Everybody thinks that holes in houses are in walls. But I will tell you, experience shows, with always a few exceptions, holes in houses generally are over your head. They tend to be in the flat ceilings or in some sort of ceiling to knee wall connection or something like that. That's where the ugliness occurs, is somehow connecting the house through a bypass leak to the attic. So just be aware of that. I say that the leakiest walls in a house are not exterior walls. The leakiest walls in a house are the wall between the house and the garage and the wall between the house and the attic. So those are ones you got to really pay attention to. So let's see. Roxanne, anything you want to add on? Why don't you do this one?
Woo. All right, so on this one, this is where, where we see a lot of air leakage is right behind tubs, because they don't have that interior air barrier. And it is now required to have the interior air barrier. And you can use something just like this. You don't have to put, something thick that might, mess up your rough end cut. You can put something like this, which is just really kind of thick cardboard, and I'll pass it around. And that has to go behind the tub. But before it can go behind the tub, what do you first have to do? Air seal and insulate. And then put that behind. The example in the upper left-hand corner is where we didn't see this happen. And so what we're kind of looking up here is a second-story master bath on an exterior wall. And that E right there is actually a porch roof. And so what's going to happen is air is going to come in through the porch roof, underneath the tub, go down what we kind of affectionately call the six-pack hole, right? That's that hole cut with the chainsaw. It's going to go into the chainsaw, or go into that hole, and now it's going to go in between the two floors. And it's going to find a can light, I assure you, and that nice, warm, moist air is going to do what on that pretty much cool surface if it's not on? It's going to condense on it, and it's going to create water, and you're going to be a homeowner sitting up there looking up going, I got a plumbing leak. And a homeowner will call the drywall or call the plumber, and they'll rip down the drywall. They'll look up there won't be a leak. They'll put the drywall back up. And a couple of months later, it'll come back again. And all it is because they didn't have that interior barrier, air barrier. And this is a problem that we'll see a lot in homes. And it's also not going to pass the blower door test because it's just so leaky. I mean, I can take you to many homes, and crank on the blower door, and the first place I'll go is the master bath just to feel. It'll give me an indication of whether or not I even need to worry about this if I'm doing diagnostic testing.
That's a good point. I've actually been in a house before that had a jacuzzi tub, and we turned on the blower door, and the access panel door for the jacuzzi tubs is like, poof, and it pops open. I think that tells you something, doesn't it? So
we don't even have that problem much anymore because I don't actually see doors on jacuzzi tub access. Yeah. What do we now see a lot? Do you guys know?
It's an upside-down return grill, yeah.
It's that upside-down return grill. And you know what? The first time I ever saw it in a home, I walked past it and I go, well, what's that? Because it was just this big tunnel of air just flowing out. And I get down there, I'm like, oh, that's not going to be good.
It's almost like a window open all the time. So, yeah, it's a problem. By the way, we see the same issue in commercial buildings a lot too, where you've got like a porch roof or something extending over. And when you move the drop ceiling up, you can see they didn't run the sheathing all the way up. And that's connected to a porch, an overhang. And then that space above us a lot of times is used as a return plenum, right? And so that plenum essentially is under negative pressure, and it pulls in lots of outside air. Raise your hand if you've ever seen a drop ceiling tile that had water spots on it. It's actually kind of nice to be in a brand new building where I don't see any water spots yet.
Yeah.
And I say yet, I shouldn't say that. So, but when you see that, people think it's well, how did that happen? Well, it's all air leakage. It's not a plumbing leak. It's not a roof leak. It's air leakage with condensation. So that's the same effect in a house. Okay. We talked about this. Windows need to get sealed into a rough opening. Same for doors. You can use backer rod or the spray foam that goes for windows. This is an important one right here. I want to emphasize this one right here. A cantilevered floor has to have this piece of blocking over the exterior wall that's cantilevered out from. Okay, that blocking is crucial right here. And of course, I think y'all remember how much R value, one more time, R30, every else floor is R19. The other one drawing I think is really good is this one right here, which very clearly shows the blocking you need from an attic knee wall. It also shows the attic side air barrier. That blocking is keeping the attic air from kind of getting in between floors. And that's exactly what our friend is. This is an attic knee wall. They didn't put any blocking. He's sticking his arm in, and this is the picture he's taking. Basically, attic air is just communicating right in between the first and second floor. And like Roxanne said, it's pretty much a guarantee this will fail the blower door test. That's pretty much a given. It will fail the blower door
and
test.
If you look, they did the attic knee wall perfect.
They did the wall.
They did the attic knee wall perfect. But they kind of forgot a really important thing, that blocking that happens at the fan joist.
I think I was going to show you another tub hole I was going to try to get at. Where is that one? Is it this one?
I don't know.
I have to do some math here, sorry.
On our joist, you got to block it if required there for lateral support anyway.
Yeah, right. That's great. You should do it. For whatever reason, do it. You don't have these slides, but I thought this was good. I took this picture. I was doing an energy assessment on a home, and I was looking around at, you always go to the trigger hotspots. And I go to this house, and I look, and I'm like, there was insulation here. I will say that. I pulled it down to take this picture because I was really impressed. Do you see that someone actually did some air sealing right here? But they kind of missed. You get the idea? It's kind of like, this is my job. This is all I do, right? I only seal around pipes, little pipes, not the big one, right? So you kind of have to, you laugh sometimes, you step back and you see the big picture. But, fixing this was not really all that hard to do. It's some low-tech, I used foam board, anything rigid. I used some caulk and some screws to hold it in place, and then I foamed the remaining gap, so nothing big on that. This is my own house. When I have a 1920 Craftsman bungalow in Decatur, and I go crawling in, I'm like, holy cow, that's the inside of my wall right there, right? Anytime you can look up and see the inside of your interior wall from your crawl space, that's not good. And guess what? Lots of stuff was getting into our house. Critters, right, can crawl in through these kind of unsealed penetrations. So, same kind of solution. I just used some caulk and some foam board and sealed it up. And Okay, so my crawl space is as nasty as they come. And y'all know what camel crickets are? Cave crickets, you know what those are? You know what I'm talking about? I know you know what they are. They're just disgusting. And I'm in my crawl space. I don't like being in a crawl space. And, I'm kind of claustrophobic or something. I don't know. As I'm working on my back. And these camel crickets, they're carrying weapons, and I'm on my back and working over my head, and this camel cricket starts gnawing on my leg, and I am freaking out. It turned out it was my dog, so it was okay. Anyway, all right, another air sealing great story, though, was we were doing this, this is a long time, we were doing this Habitat Blitz build, and we were staying in somewhere in Appalachia, Tennessee, and we stayed in, I want you to envision a Norman Bates motel. Are you getting the visual here of this? So we're staying in the Norman Bates motel, and we were in kind of one set of rooms, and a few doors down was some other folks were staying, and they happened to be with a traveling reptile show that happened to be in town. And one of the reptiles apparently crawled from this guy's room 3 doors down, and for whatever reason came into one of my coworkers' room, and it crawled through unsealed plumbing penetrations. And so that is a 5-foot python. So I don't know, if air sealing for crickets and termites and other stuff doesn't convince you, air sealing will stop pythons. That's my message to you, okay? So I'm not sure what was scarier, the snake or this guy's hairy back, but you can do anyway, all right, enough stories on that, so we'll go forward. Other air sealing, I think I had something here I wanted to show you. This is a great photo we took from our weatherization training. Mm-hmm. You're in the attic looking at the access door to the attic. That's the bedroom, and this is a knee wall right here. You see the missing blocking right here. So in existing homes, we go in, and if you can see this plaster last ceiling, that's not a good sign. What's this right here? The old knob and tube wiring. So you gotta take care of that first. You gotta disable that, and then you can block this, and then you can fill it with insulation. This is another picture of an attic knee wall from the attic side. That's the knee wall right there. That's the vault right there. Do you see that? And that's a vent baffle right there. Do you notice anything about the color of this fiberglass bat? Yeah. So what's been happening in this bat? It's been acting as a filter. The homeowner in this house had real bad comfort problems in their bonus room, which was on the other side of this wall. We took a thermal camera and we shot the inside temperature of the drywall of the bonus room was 104 degrees. That really sounds comfortable in the summer, doesn't it? 104 degrees on the inside of your house. And what was causing hot air to go through the insulation? Well, one is they probably didn't have the baffle correctly done. They should have blocked it here. They should have had an air barrier and more insulation here. But the real thing that was really driving all this, a stupid power attic vent fan. You see it? You see the power attic vent fan was up on the top, and it was sucking attic air right through the insulation, basically negating the insulation. Get it? Okay. Here's another great one. I took these pictures in Kentucky. We thought this looked really good. We were really proud of them. They did some. That's really not approved foam, but we were proud that they put a foam air barrier on the backside of the knee wall. But then there was a place where I guess the wall got taller than the board, so they just kind of remember that. Just think what a thermal camera would show on that one. Here's my favorite one though. Was we're walking along and there's this wall, and we're like, what is going on over here? There's this wall with what are these things? And these were drawers, and you go around to the attic side, and you're like, well, I guess your sweater is your building envelope. So great stuff.
It's your clothes dryer.
But man, this sweater's itchy. It's custom, right. So we've talked about attic access and other things like that. But so air sealing, very important. Lots and lots of good pictures, lots of good stuff, and we'll push forward. So Roxanne, we got to do a test on our air sealing.
And so the test for the air sealing, again, is that blower door test. For single-family new construction, it is required on all homes. For multifamily, you do get 2 pathways, either that 1 in 4 per floor test out, or you can do the checklist in every unit for 2 visits. The another exceptions are renovations. If your renovation doesn't touch every component in the house or is a gut rehab, you do not need to do a blower door test, which means additions. Do you need a blower door test? Nope. For additions. For
Partial renovation.
partial renovations, do you need to? Nope. For a complete head-to-toe, wall-to-wall renovation, do you need to? Yes. And the threshold for your envelope tightness test is 7 air changes per hour at 50 pascals. Essentially what that means is the volume of the house has to exchange no more than 7 times in an hour period when I depressurize your house at 50 pascals. To kind of let you know, this threshold should be fairly easily attained, especially if you're following all of those checklist items. But again, large holes, if you're looking from the attic side down and you're looking into a chase and you can see drywall, that's just probably not going to cut it.
I agree with that assessment. I think for the most part, the bar for how tight do you have to be is reasonable, but it's certainly not excessive. We make houses tighter than that all the time, and if you just do the air sealing that's required, you should hit this target every time. So just in case you're wondering, the way this calculation works, it's actually over here on the corner. When you do a blower door test, you set up your blower door, and you can either pressurize the house, meaning blow air into the house, or depressurize the house, suck air out of the house, and you'll create a difference in pressure between the inside and the outside of 50 pascals. That you're like, what does that mean? I'd never heard of that till I started doing this. 50 pascals is not that much pressure, but it's enough to kind of test at an elevated level that negates things like the wind or the stack effect. You do turn off all the fans in the house before you do this test. To give you an idea what 50 pascals is, so you got a cup of water or something here, and you stick a straw in it, right? And you put your finger on the straw and you lift it out. And let's say there's an inch of water column in the straw, right? You know what I'm talking about? And that is putting a certain pressure on your thumb. It's an inch of water column. And actually the HVAC world uses that terminology, inches of water column. Well, an inch of water column is 250 pascals. So what we're really doing is saying let the water out of the straw until you've got 0.2 inches of water column, less than 1/4 of an inch of water column. That's a 50 pascal pressure difference that you're feeling on your thumb. So it's not going to, it's very safe to do this test.
I'm going to ask, does that mean that you're going to be able to breathe during this test while you're inside the house? Yes, it's not going to suck the air out of your lungs.
Will your contacts stay in
your eyes? Are your contacts
and
going to pop out? No. Are your ears going to pop? No.
Probably not. But it is an accelerated test pressure. So in other words, how many CFM for any given house does it take to move through the blower door to create a difference of 50 across the envelope? And that number we refer to as the CFM 50. Okay? So once you get that number, let's just say that number is 2,000. 2,000 CFM 50. That's the answer. You get that number from the blower door. Once you have that number, you plug it into this equation over here. You take the CFM 50, you multiply it by 60. That's because 60 minutes in an hour. In other words, cubic feet per minute times 60 minutes in an hour. What you're doing is converting it to cubic feet per hour at 50 pascals, and then you divide by the volume of the house in cubic feet. Okay? If this means nothing to you, don't worry about it. Somebody else's job is to know how to calculate this. But that's basically what it is.
If you're interested in this, take our DET verifier.
And you can take a class or go look at our website. We've got a good little frequently asked question thing about this topic. But essentially, the calculation has to end up being, this number has to be less than 7. So if you think about the volume of your house, let's just say you had a simple 1,200 square foot house with 10-foot ceilings. What's the volume? 12,000, right? 1,200 square feet times the ceiling height, 12,000. That's the volume of your house. What you're saying is that if you left the blower door on for an hour, keeping the house at 50 pascals, that volume would change out no more than under 7 times in an hour. That's another way of thinking about it. The entire volume has to change out less than 7 times in an hour. It does not take an hour to do a blower door test. It
Takes
literally
about 60 seconds.
Yeah, well, I mean, setting up the equipment is let's say 5 minutes if you know what you're doing. Turning on the test is 10 to 60 seconds. So it's a pretty quick test. To once it's set up, it's pretty much instantaneous.
So the person doing it has to go through and do all the measurements. Like you got different ceiling heights, different rooms, all the ceilings. They've got to.
You have to calculate the condition volume. So a lot of times, if you have the plans, that makes that easier for sure. And the other thing too is generally if the volume is, you know, if you're reasonably close on the volume, if you calculated that the volume was 11,800 and I calculated it was 12,200, it's not going to make the answer affected by very much. So you get reasonably close, it's probably okay.
But yes, if I could have square homes for the rest of my life.
Well, no, and it's always, all areas and volumes are always measured from the exterior. And do you remember we had that problem? Do you remember what slide it is? I'll guess 45. Close. Is this it? Yeah. Remember this problem we had earlier? If this is your house, let me give you, see if you can answer some questions. Let's say I've got a stair in all of these 3 houses, a stairs with a door that goes down, and I've got a pull-down stairs that goes up. Okay? If I'm testing this house with a blower door, what's this door going to be, open or closed?
Well,
No.
remember, where's our building envelope?
It's going to be closed. What about the pull-down stairs? Closed, right? Okay? So, because the volume of the house is what's inside the dotted line. If I go to this house, is the stairs going to be, the door to the stairs going to be open or closed? Open, and the pull-down stairs would be closed. When I go to this house, open and open, right? Because you're trying to calculate for the entire volume of the space, okay? And yes, the answer for calculating the volume, whoever was asking, would be different answer on each one of those. Does that kind of make sense? Okay? Yeah, it's always measured, for better or for worse, measurements are always done on the exterior. Yep. We use exterior. That's a consistent thing. It's an ASTM process of measuring floor areas and volumes. Yep.
So those where they insulate the rafters, we'll say,
The roof line. Yep, spray foam the roof line.
but it's not finished space.
You open the stairs to the what used to be an attic.
Because that is still considered conditioned space. Remember, it's that indirectly conditioned space.
Yeah, good. Thanks for mentioning that. Everybody catch that? So the blower door test is pretty doable. And does anybody have any questions on it? If you want to watch a little video of it, I think we put a link to about a 10-minute video or something about. Actually, I think there's like 10 or 15 minutes of how to set it up, and then 10 or 15 minutes of what you do when it's on and stuff like that. You can do all kinds of stuff with a blower door besides just verifying the tightness of a house. You turn off bath fans, you turn off clothes dryers, you turn off any fans in the house, but you don't tape anything over. And one reason why we usually depressurize houses is because dampers will be pulled closed. Think about your dryer damper. It'll be sucked shut. So that's why we usually depressurize.
At final, I'll say.
You do not tape the HVAC vents for this test. You will have to tape them for a duct leakage test. Is it? Times 60 over 12,000.
Hold on.
I don't know what that number is. Okay, then you would fail. Yeah, thank you. I'm making up numbers on the fly. So yes, you would fail. So that house, but if that house was like
well, it's got to be less than 7.
Instead of 2,000, if that number was like 1,500, it probably would pass. That's a small house.
All right, and let's make some clarifications here.
Okay.
This test is performed at final. So after, all your drywall is up, after your finished floors are in, it is usually the last thing done in a house besides maybe your little punch list.
Yeah, the only time you could ever do this test at rough-in is if they had foamed the roof line, because there's no air barrier, there's no flat ceiling up there, you can't test the house, right? You have to have the air barrier in order to test the house.
And then in addition, as it was brought up, is, okay, Great if it passes. Everyone's happy. What if I, as the DET verifier, go out there and I find, all right, your house is rating at about 10 air changes per hour at 50 pascals, or that 10 ACH 50. You're no longer pass. Well, then I might provide you an additional service where I go around the house and I say, all right, let's find all the places that are leaking in this house. And you can take a smoke pencil. You can also go around and actually typically feel wind blowing. One of the first places I would go is, again, that spa tub.
I'm going to say, I bet Roxanne could find it without even using the blower door.
I bet you I can just like go around, turn the blower door on, run into like 4 places that I know it's going to be leaking, and just tell you that you got to focus on here. Whose responsibility is it to fix those problems? Is it my responsibility?
You're the tester.
Nope, I'm the verifier. It goes back to the builder. And however the builder wants to take care of it, they got to take care of it, because they will not get your certificate of occupancy without this.
So, yeah, this is important. Yeah, Tony.
Okay, so let's say this scenario, you got the basement walls insulated, so that door going out the basement will be open.
Yep.
You've got a gas furnace and gas water heater down there. What do you do about the vents, the gas vents?
Those are holes in the envelope.
That are always there.
And you definitely, to do a blower door test, a lot of the class that we teach is how to safely do a test. You would never, ever, ever want that water heater to fire during a blower door test, because you know it would backdraft.
But
you
yes,
have
you do
to
not
basically
close those vents.
You do not tape anything over. That represents a leak. That represents a leak. Now, if they had a excuse me, something like a direct vent water heater, then that wouldn't be a hole. So, but the answer is, there's a protocol to safely take care of that during the test. But yes, it counts as a hole. That is a hole. That's a 4-inch or 3-inch vent pipe, whatever the size that is.
Other holes that we see are fireplaces. If that fireplace doesn't have a damper, it remains open. I will never tape that. If that fireplace has a damper, I will close it, but I won't tape over it again. I also won't tape doors together. The only time I've ever really used tape is to make sure that a attic knee wall door won't pop open while I'm doing the test. Again,
Right.
Not to actually like seal the whole door. I just take a piece of tape and I say, stay shut, door.
But I have those gas vents. The air that's we bringing in would not be enough to.
Well, basically, okay, here's an important thing. If you've got stuff in a basement, you really don't want to use the air in the basement as combustion air. What we want you to ideally do, what we want you to do is isolate those units from the main basement, and in other words, build a closet around them and bring in high load to that closet. Or to use direct vent water heaters or high efficiency sealed combustion furnaces. Because otherwise, if you think about it, if you say, okay, I'm insulating the walls of my basement, now I'm going to cut a hole in the wall for high-low vents, you just violated the code. You violated the energy code to satisfy the mechanical code. So you don't want to, in essence, seal up the basement and insulate the walls and then cut holes in it. If you need to make a closet that the equipment's in, that's one thing. But we can talk more about, is that good? I mean, we can spend more time. Does anybody have any other blower door testing questions? So if you ever want to come and sort of sit in on one, our Earthcraft Inspect TAs, technical advisors, are happy to take you along if you ever want to watch one. Okay, any questions on that? Let's talk about ductwork.
Oh, hold on. John,
Sorry, one more question.
John, you got a question? John? You got a question?
So, no.
All right.
Okay.
All right, so the other one that we're going to do, so if your ducts are not inside conditioned space, we actually have to test how leaky they are. Do you want to run the test now or go over the...
Let me try to give a quick explanation before
Okay.
we do this, and we'll talk about the numbers in a minute. Basically, there's sort of 2 kinds of duct leakage. There's a test that we can do where, in essence, we just come to a duct system, we sort of treat it like your car tire. We blow it up with air, and we see how leaky it is. Okay? And that's the one we're going to be able to demonstrate for you. We call that the total duct leakage. Okay? If that duct system is entirely located in the attic or partially in the attic or partially in the house, some of those leaks, if part of the duct system is in the house, some of those leaks might actually leak to inside the building envelope. Correct? And those leaks, you could argue, if there's a duct that's running across this room and it leaks into the room, it's not really leaking outside the beer cooler, right? So there's another test we can do called the leakage to outside test, where in essence we can eliminate the leaks going into the house. We use a blower door and a duct blaster, and we can eliminate the leaks coming into the house. We can only measure the leaks that are going into the attic, and that's called leakage to outside. So there's, let me say it one more time, there's kind of two kinds of duct leakage. Total leakage, blowing up the balloon, and leakage to outside, only the leakage that's lost to the attic or lost to the crawl space. And to further confuse you, you can do the total leakage test at rough-in or at final, but you can only do the leakage to outside at final. Okay, so having said all that, let's take a look at what duct leakage is all about. We're going to need a volunteer for this?
A volunteer.
All right, so we need a volunteer. I think we need an HVAC guy.
One quick question.
Okay.
We're trying to figure out. You've got your gas unit
You volunteer?
downstairs. You got a gas hot water heater. That's in a closet. Those are going to be a louver closet because you have to have that for the
You should not do that. You should not do a louvered closet.
You can't use a natural draft water heater inside the inlet.
That's right. You should not do that. You should put us.
a 4-inch like direct vent.
Yeah, direct vent is great, or a combustion closet.
Well, leave it at that, and then you got your fireplace, which has got outside air kit. But you can't. I guess you can't cut.
You can.
Yeah, you
cut
can
the
close
damper.
off the outside air.
And, so when you're doing that, those two are not pulling out enough out of that 0.7 to make any difference, right?
Well, they might.
They
They
might.
might.
All right,
But
if you do, is there a calculation then they can use to say, okay, you got this, but it's just not going to pass?
no.
No.
Okay. So. All right. No, it's okay. It's a good question.
Am I making sense what I'm trying to get at? If
Yeah. Yeah, you are.
It's not going to pass.
No, you're asking. Okay.
So what he's asking, let's start with that.
Okay.
What I'm trying to figure
Well, here,
out,
let Mike.
you got those two pipes down there with your
Yeah.
heating and air unit and your hot water heater is gas. It's going to be pulling something
All right.
out of
Here's what we want you to do. I want you to think about this. Combustion equipment and people both need air, correct? Is everybody with me on this? Combustion equipment and people both require air. If you all are the combustion equipment and we are all the people, I want you to have your own air and I want us to have our own air, and your air does not mix with our air. Okay? In other words, if you're a water heater and you're a furnace, and I don't know what you are, you're a gas clothes dryer, I want y'all to be in a chamber, like a closet, that is sealed off from me out here in the main part of the house. Okay? So I'm in the main part of the house, and you're in what we call a combustion closet. And what do we need to provide to this combustion closet so that they get what they need? These things called high-low vents, right? You ever heard that before? High-low vents? The amount of high-low vent that you need, the size of the pipe in essence, is a function of a couple things. Mainly, how many BTUs do y'all add up to be? Okay, and there's a rule. If the pipe is all vertical, it's like 1 square inch of opening for 4,000 BTUs. If it runs horizontal, it's 1 square inch for 2,000 BTUs. And it's all in the mechanical code, just where this comes from. But the idea being that safe combustion puts your issues separate from my issues. And we want to air seal this closet from the rest of the house. Okay? That's the safe concept of how to provide combustion air for y'all and not mess with me.
So,
when I blower door test on this part of the house, that's in essence sealed off. Does that make sense?
So is this in the building envelope?
Kind of, not technically.
No, not technically.
No, it really isn't.
Because you built the building envelope to be this wall.
Yeah.
The floor above it.
Technically though, if you've done something like that, wouldn't you have to put a closure or something on there to make sure it stays closed?
I mean, this is where, in my opinion, the mechanical code has not always caught up to building science. It's a little weak on some of these details. But yes, best practice, you would want that. You would want the combustion equipment to be in a closet that was really sealed off from the house and therefore very safe. That, by the way, we can also, and I think, John, you mentioned this, we can also replace this standard atmospherically vented water heater with something called a direct vent water heater. A direct vent water heater basically has an exhaust pipe that is going out, and then wrapped around that is a bigger pipe that has combustion air coming in. It's sort of like the closet is built around the water heater itself. Does that make sense? And that is very safe, and that is what we want. That is
Very
exactly
cool.
what we want.
It's just gonna be a matter of getting.
But it just can't be within the envelope of where you're sucking from.
I mean, if it is in the envelope, then you're gonna suck hard.
So,
All right.
yes.
That's really unless it's direct vent. A direct vent is absolutely fine. Direct vent, you can side vent, or you put a closet with high low. Yep. Or you put the water heater in the garage. Okay. Woo.
Woo. Guys, you're wearing me out.
So
All right.
let's talk about duct blaster.
All right, hold on.
We got one or two things we can do here. We can go to all electric appliances. We don't have to worry about that. Or if it does leak enough there, I'm sure y'all want, and what I see here is you want to test it in the main operation that the house is going to stay in.
There you
It's
go.
not going to be taped off. From
That's
that.
There you
correct.
go.
That's
You
right.
got it.
So in other words, if that doesn't pass on account of that, if everything else is tight in the house, then you have to build a combustion closet
Well,
around it and provide
Yeah,
that.
in our opinion, you should always do that anyway.
In
I mean,
our
really and
opinion, you
truly, because
I
you
don't
just
ever
want
wanna
people
breathe
air and
combustion
combustion air
air.
separate. It's a very good question. When I'm in charge of all the codes and when I rule the universe, this will be very clear. No one will have questions about it.